To back up a 300 amp service with a 20 kilowatt generator and load shedding, consider a few options. Firstly is the Honeywell ATS option. The Honeywell S60540 PS is a 400 amp automatic transfer switch with double lugs. This allows for connecting both feeders and loads directly to the switch. You could install this automatic transfer switch outside near the meter, connecting the 300 amp service to the line lugs and the generator to the generator lugs. Then divide the load between the two 150 amp subpanels and use load shedding to manage the load and the generator when necessary. Secondly, there is the automatic transfer switch with load shedding and subpanels option. You would install a 300 amp main breaker outside by the meter. Use an automatic transfer switch with load shedding capabilities, such as the Generac Guardian 7049, to switch between utility and generator power. Connect a 200 amp subpanel to the automatic transfer switch for essential loads. Install 2 additional 150 amp subpanels to handle the remaining circuits. Use load shedding to manage the total load in the generator and prevent overloading. Additional considerations are important. Ensure that all electrical work complies with local and national electrical codes. Determine which circuits are essential and which can be shed during a power outage. Verify that the 20 kilowatt generator has sufficient capacity to power the essential loads during a power outage. Consider the transfer time of the automatic transfer switch, which can range from 10 to 30 seconds. This can impact the operation of sensitive electronic devices. The cost of either option will depend on the specific equipment used and the complexity of the installation. It is recommended to consult with a licensed electrician for an accurate quote. Load shedding is a crucial aspect of using a generator to back up a larger electrical service. A 20 kilowatt generator has a limited capacity and it's unlikely to handle the entire 300 amp load simultaneously. Load shedding involves selectively disconnecting non-essential circuits during a power outage to prevent the generator from being overloaded. Here's how to approach load shedding. Firstly, identify essential circuits. These are the circuits that must remain powered during an outage, such as lighting, refrigerators, medical equipment, and critical communications devices. Secondly, identify non-essential circuits. These are circuits that can be temporarily disconnected without causing significant inconvenience, such as electric stoves, clothes dryers, air conditioners, and non-essential lighting. Thirdly, implement load shedding controls. This can be done manually by turning off breakers for non-essential circuits when the generator is running, or automatically using a load shedding module. A load shedding module monitors the generator's output and automatically disconnects non-essential circuits if the generator approaches its maximum capacity. Fourthly, consider a staged approach. You can prioritize load shedding by disconnecting the least important circuits first, followed by progressively more important circuits if the generator continues to be overloaded. For example, you might disconnect the electric water heater first, followed by the air conditioner, and then the electric stove. Fifthly, label circuits clearly. Clearly label all circuits in the electrical panel to indicate whether they are essential or non-essential. This will make it easier to manually shed loads if necessary. Sixthly, test the system regularly. Periodically test the generator and load shedding system to ensure that they are functioning correctly. This will help you identify any potential problems before a real power outage occurs. Seventhly, consult with a qualified electrician. A qualified electrician can help you design and install a load shedding system that meets your specific needs and complies with local electrical codes. They can also advise you on the appropriate size generator for your essential loads. When selecting an automatic transfer switch, consider the following factors. Firstly, amperage rating. The automatic transfer switch must have an amperage rating equal to or greater than the service it is protecting. In this case, a 400 amp automatic transfer switch would be suitable for a 300 amp service. Secondly, voltage rating. The automatic transfer switch must have a voltage rating compatible with the electrical system. In most residential applications, this will be 120 volts or 240 volts. Thirdly, number of poles. The automatic transfer switch must have the appropriate number of poles for the electrical system. For a single-phase system, a 2-pole automatic transfer switch is typically required. For a 3-phase system, a 3-pole automatic transfer switch is required. Fourthly, transfer time. The transfer time is the amount of time it takes for the automatic transfer switch to switch from utility power to generator power. A faster transfer time is generally desirable, as it minimizes the interruption of power to critical loads. Fifthly, load shedding capabilities. Some automatic transfer switches have built-in load shedding capabilities. These automatic transfer switches can automatically disconnect non-essential loads if the generator is overloaded. Sixthly, monitoring and control features. Some automatic transfer switches have advanced monitoring and control features, such as remote monitoring, remote control, and data logging. These features can be useful for managing the generator and electrical system. Seventhly, certification. Ensure that the automatic transfer switch is certified by a recognized testing laboratory such as Underwriters Laboratories. This will ensure that the automatic transfer switch meets safety standards. Here's a breakdown of the Generac Guardian 7049 automatic transfer switch. The Generac Guardian 7049 is a 200 amp automatic transfer switch designed for use with Generac generators. It has built-in load shedding capabilities and can automatically disconnect non-essential loads if the generator is overloaded. The Generac Guardian 7049 has a transfer time of less than 1 second, which minimizes the interruption of power to critical loads. It also has advanced monitoring and control features, such as remote monitoring and remote control. The Generac Guardian 7049 is certified by Underwriters Laboratories. When installing a generator and automatic transfer switch, it is important to comply with all applicable electrical codes. Electrical codes vary depending on the location, so it is important to consult with a local electrician to determine the specific requirements. Some common electrical code requirements include the following. Firstly, proper grounding. The generator and automatic transfer switch must be properly grounded to prevent electrical shock. Secondly, overcurrent protection. The generator and automatic transfer switch must be protected by overcurrent protection devices, such as circuit breakers or fuses. Thirdly, wiring methods. The wiring methods used to connect the generator and automatic transfer switch must comply with the electrical code. Fourthly, clearances. The generator and automatic transfer switch must be installed with adequate clearances from combustible materials. Fifthly, signage. The electrical panel must be clearly labeled to indicate the presence of a generator and automatic transfer switch. Sixthly, permits. In some jurisdictions, a permit is required to install a generator and automatic transfer switch. Regarding the Honeywell ATS 60540 PS, this automatic transfer switch is a 400 amp automatic transfer switch designed for residential and light commercial applications. It has double lugs, which allows for connecting both feeders and loads directly to the switch. The Honeywell ATS 60540 PS has a transfer time of less than 1 second and is certified by Underwriters Laboratories. Here is a step-by-step guide on how to install an automatic transfer switch. However, it's crucial to emphasize that this is a general guide, and you should always consult with a qualified electrician for professional installation. Working with electrical systems can be dangerous, and improper installation can lead to serious injury or property damage. Firstly, safety precautions. Before starting any electrical work, disconnect the power to the main electrical panel. Wear appropriate personal protective equipment, such as safety glasses and gloves. Work in a well-lit and dry environment. If you are not comfortable working with electricity, hire a qualified electrician. Secondly, select a location. Choose a suitable location for the automatic transfer switch. The location should be dry, well ventilated, and easily accessible. The automatic transfer switch should be mounted on a sturdy surface. Thirdly, install the automatic transfer switch. Mount the automatic transfer switch on the chosen surface. Connect the wiring from the main electrical panel to the line side of the automatic transfer switch. Connect the wiring from the generator to the generator side of the automatic transfer switch. Connect the wiring from the automatic transfer switch to the subpanels. Fourthly, install the load shedding module. If using a load shedding module, install it according to the manufacturer's instructions. Connect the load shedding module to the automatic transfer switch and the non-essential circuits. Fifthly, test the system. After the installation is complete, test the system to ensure that it is functioning correctly. Turn on the generator and verify that the automatic transfer switch switches from utility power to generator power. Verify that the load shedding module disconnects the non-essential circuits when the generator is overloaded. Sixthly, label the panel. Clearly label the electrical panel to indicate the presence of the generator, automatic transfer switch, and load shedding system. The generator's capacity is a key factor in determining which loads can be powered during an outage. A 20 kilowatt generator can typically provide around 83 amps at 240 volts. This means that the total load connected to the generator should not exceed 83 amps. To determine the total load, add up the amperage of all the essential circuits that will be powered by the generator. The amperage of each circuit can be found in the circuit breaker or in the electrical panel schedule. If the total load exceeds 83 amps, you will need to shed some of the non-essential loads. The transfer time of the automatic transfer switch is the amount of time it takes for the automatic transfer switch to switch from utility power to generator power. A faster transfer time is generally desirable, as it minimizes the interruption of power to critical loads. Automatic transfer switches typically have a transfer time of between 10 and 30 seconds. However, some automatic transfer switches have a transfer time of less than 1 second. These automatic transfer switches are often used to protect sensitive electronic devices, such as computers and medical equipment. The Honeywell ATS 60540C is another 400 amp automatic transfer switch option. Be sure to compare its specifications and features with the ATS 60540PS to determine which one best suits the needs. Remember to carefully evaluate the power requirements of your essential loads. Consider the starting wattage of appliances, which is often higher than the running wattage. Appliances like air conditioners and refrigerators require a surge of power to start, which can briefly exceed the generator's capacity. The load shedding system should be designed to handle these surge loads. Also, consider the future. As your power needs change, you may need to upgrade the generator or the load shedding system. It's a good idea to choose a system that can be easily expanded or upgraded in the future. Proper maintenance is essential for ensuring the reliable operation of the generator and automatic transfer switch. Follow the manufacturer's recommendations for maintenance, such as changing the oil, cleaning the air filter, and inspecting the spark plugs. Regularly test the system to ensure that it is functioning correctly. Keep a record of all maintenance and testing activities. This will help you troubleshoot any problems that may arise. Consulting with a licensed electrician is crucial for ensuring the safe and proper installation of a generator and automatic transfer switch. A licensed electrician can assess your electrical needs, recommend the appropriate equipment, and install the system in accordance with all applicable electrical codes. They can also provide guidance on load shedding and other aspects of generator operation. When comparing different automatic transfer switches, consider the warranty. A longer warranty provides greater peace of mind and protection against defects. Read the warranty carefully to understand the terms and conditions. Another important consideration is the noise level of the generator. Generators can be quite noisy, especially when running at full capacity. Choose a generator with a low noise level if noise is a concern. Consider installing the generator in a soundproof enclosure to further reduce noise. The installation location of the generator should be carefully chosen to ensure adequate ventilation and to prevent the buildup of carbon monoxide. Never operate a generator indoors or in an enclosed space. Carbon monoxide is a deadly gas that can be produced by generators. Install carbon monoxide detectors in your home to provide early warning of carbon monoxide buildup. Always follow the manufacturer's instructions for operating and maintaining the generator. Improper operation or maintenance can damage the generator or create a safety hazard. Keep the area around the generator clear of debris and flammable materials. Store fuel for the generator in a safe location away from heat and sparks. Be aware of the potential for power surges when the generator starts up or shuts down. Consider using surge protectors to protect sensitive electronic devices. If you are planning to use the generator for an extended period of time, consider installing a permanent transfer switch. A permanent transfer switch is safer and more convenient than using extension cords to connect the generator to your electrical system. When selecting a generator, consider the fuel type. Generators can run on gasoline, propane, or natural gas. Each fuel type has its own advantages and disadvantages. Gasoline is readily available but can be expensive and may require stabilization for long-term storage. Propane is cleaner burning than gasoline but requires a propane tank. Natural gas is the most convenient fuel type if you have a natural gas line.